Hello everyone, and welcome to our team OrderHere's final demo. And today's demo is divided into two main segments. And the first part will be presented by our developer group. And following that, the second part will be led by our DevOps team. And we are so excited to share with you the work we have already made and the collaborative efforts that have brought us here. Okay, so let's Steven to demonstrate our website first.
Hello, Stephen here. So first, let me guide you have a look at the hosted website. So basically, we can say you can see all the dishes. So up on the top, we have a search bar. We can search by the dish name and the dish price and the descriptions as well. And we have a pricing filter here. Basically, it's just dragging that through and we'll filter out all the prices which is in between. And we can show all the store information. And we can add some dishes to the cart. And we can pick delivery, pick up, dining, or clear the cart as well. And also we can log in as a admin, so it will bring us to the admin page, which we can edit all the dish and restaurant. So because the hosted version is probably a few commits behind our GitHub repo, so for the rest of the demo, I'll use my local host. Back to my local host. So the first thing I want to share is we can use Google login. So I can use my Google account. So it will continue. And basically I'll drag all my avatar and my username and my role to this app, and it will work for all the ordering and the other process. So let's log out. And next, I will log back to the admin again. So we can delete and add new dish from our admin account. So if I can delete that and I will refresh, it will disappear. And I can add the kimchi back again if I want. So it's appetizers. It's kimchi, and I will add dish. That's kimchi. And I can filter that through. It's kimchi, it's over here. And on top of that, we can set the ingredients for each dishes. And also we can change the image for each dishes and the price. We can change that to 14.49 as well. So I'll come back to 14.49. And here I can add ingredients such as egg. So you can save. So once the customer, they want to add them in the cart, they can select to choose whether to have those ingredients or not. So now let's go to the store information. And basically, you can add all the restaurant information as well, but I can change the address for the restaurant as well. So here is 123 Queen Street. So I probably will say 100 North Terrace, which is Adelaide. If I can update, it will show the Google map will show it. We are in Adelaide at the moment. So here's the edit of restaurant information. Now, just log back to the, if I can sign up for another user, which is a customer, and I can use, or should say, probably 10.gmail.com. I can assign a new customer, and it will show up over here. I can go and edit my avatar. And I can change my name Yeah, so I can change my name and address as well from here. So I just come back and it will show up in the pop-up. And I can add those dishes into the cart, add more, and go to the shopping cart. So it will give us three options, one delivery, one pickup, and one dine-in. So in this time, I will through delivery, and I can input my phone number and address. I'll probably Australia, Sydney, and note. Well, I would just say that's note. I can check out and make a payment. And I'll pay now. So once the order has been confirmed, I will get through this page to show the order number, delivery address, distance, and the order status, and we're back to home. I will go to order history, and I can see my order here from here. So I can show the delivery address and everything. So yeah, if I go back to the admin again, on admin, it can order all the orders from all users. So I scroll down to see the recent order that I just made from my account. So the status is preparing. Once the delivery person he pick up the order, we can modify the order. We can say that's in transit and we'll save. And by the way, these search bars can search all the numbers by the price and the order ID. And these are all works, basically, the ticking filters. So finally, if I log out, there's a count for the deliverable person as well. So I would just say that's driver. So once the driver log into his account, he will navigate to all his order lists. So the most recent order I just made is here. It's that I just did a few minutes ago. And it will show the delivery address and estimation time and distance. So you can see the status is in transit. I just set minutes before. So once the order has been delivered, the delivery person can set that status to delivered, and I will refresh the page again. So yes, it's delivered. So that's all for the demonstration. Next, the Robin will show us all the technical stuff.
Okay, so next I will introduce you some text that mainly used in our project. And let's begin with the front end, where we leverage React. Its component-based architecture means we can reuse code and manage state in an encapsulated manner. And this makes our website not just fast, but also scalable. In JSX, a syntax extension makes it straightforward to write these UI components, while the virtual DOM ensures swift and efficient updates to the UI, a crucial factor for a seamless use experience. And integrated with React, we have Redux for state management. Redux is a vital role in maintaining the consistency of our application state. For example, the user infos after logging and dishes user added to the carts. And let's move into the backend. We have embraced Spring Boot. It comes with an embedded Tomcat server, eliminating the need for external setups. Furthermore, its readiness for microservices architecture makes it an ideal choice for a scalable, robust backend. For the database migration management, we utilize Flyway. This tool is crucial for our database's version control, enabling smooth and efficient schema changes. Flyway ensures that as our application evolves, the database transitions seamlessly, aiding in continuous deployment and integration. Next is some other essential services to enhance our user experience. For the authentication, we've implemented Google and Facebook login, making the sign-in process simple and secure. Stripe has been integrated for payment processing, ensuring secure and hassle-free transactions. Lastly, we use MinIO for image storage, offering a scalable solution for managing the large volume of images such as the dish pictures and user avatars. The synergy of these technologies creates an optimal blend for performance, security, and user experience. Thank you, and that's all for our developer team. Next, I will pass it to our DevOps group to share the deployment part.
Good evening, everyone. Now we will introduce our DevOps process. This is our AWS account organization and Jenkins server info. Firstly, I will talk about the architecture we used for the front end. Next, please. We have utilized AWS Route 53, which is hosting the registered domain website and configure the traffic, and Vercel, which is connected to the GitHub repo directly and able to deploy the static website. Next, please. I will introduce our primary CI/CD pipelines, hosted on the AWS EC2 servers. We've established multiple environments and CI/CD pipelines, empowering our development team to constantly release updates into production using Jenkins. Upon setting up the webhook in the GitHub repo and providing the appropriate access token for Jenkins, the pipeline is triggered when code is pushed to a specific branch. The main front-end pipeline installs the required Node.js packages, builds the artifacts, and the entire front-end package is then uploaded to Vercel. This directly deploys the static website to a specific domain. For the backend pipeline, the backend content is firstly Dockerized into a distinct image, isolated with a version tag, and then pushed to the ECR for deployment. Next, please. As previously mentioned, I'd like to highlight our use of Vercel for web deployment and the connection between the front and back ends. Prior to deploying the project, the domain name must be verified by adding the appropriate verification record, including specific type and values on Route 53 DNS records. Vercel should have access to GitHub repo with the correct token to allow Jenkins to access Vercel. We have already created a specific Vercel access token for Jenkins use. Additionally, the environment variable used to connect the front and back ends can be managed and added through Vercel. By adding the appropriate endpoint address, which is the load balancer address, at the Vercel environment variable field, the static website can connect to the backend part, which is already demonstrated by the developer. Next, I will pass to Ilya to introduce the backend structure.
This is our proposal, and we have already achieved DevOps with GitHub Action and Terraform. Next, use Terraform to build the AWS backend infrastructure, including VPC, ECS device, ECS service, ECR repository, Grafana. For example, we build such as network environment to connect the ECS service and the target group in same VPC. Terraform allows us to define infrastructure as code, which means we can describe cloud resources and configurations in a code. This leads to great consistency, repeatability, and virtual control for cloud infrastructure changes. Next. Our GitHub action runs those steps from login AWS, build the Gradle file, and push to ECR image. Finally, it would update the ECS service. GitHub Actions enables us to automate various workflows from code testing in developers to DevOps deployment. By defining them as code in our common repository, each update in code would trigger action to push the latest image into AWS. And the next part would introduce the by vendor. Thanks.
Hi, this is our
structure. We have like two parts of backend in different regions. So the ECS part is for the backup. I'm going to introduce Amazon EKS part. For the VPC, we have INET gateway, public subnet, private subnet, and also S-Ray for Terraform state and DynamoDB for retrieve the state log. Also, we push the minimum to S-Ray, so the pictures can be retrieved from this bucket. And next. For the EKS cluster, I've created these roles for the EKS and autoscaler. I want to say the ALB controller is used for the pods because there's pods in the new groups, so we should get rid of the traditional EKS way at the listener roles and also forward in the target group. So we use ALB controller instead, and the external DNS is help to manage the EKS DNS addresses like Route 53 does. So I've created IAM policies and attached to the role, and also I've included a CSI driver, which is trying to enhance the communication between the Kubernetes and storage system. Next, after that, we deploy the Docker image to pods and connect to RDS database. I've created RDS separately in order once the pod is done, the database will still survive. So we get this output, and I've added AWS ACM cert, so we can see the port forward to 443 port. So this is backend endpoint link, and within the health check, you can see all the restaurants from the listed from the database. Next. So for monitoring, I've used Helm charts. Helm charts is a very common tool to help us install these tools and charts for the EKS. So I've employed Prometheus and Grafana. These two pictures is what we've got for the Prometheus metrics, and also the next one is dashboard for the Kubernetes systems monitoring the CPU utilization, something like that. And also I had a value to do the S-Ray backup shortcuts for the pods, application pods. And I've also implemented the Fluent bits, so it will collect the pod logs and push to CloudWatch. Next. So this is what we got. The first one is S3 backup shortcuts, and the next one is log groups. You can see we have all these logs created by different namespace, like the OrderHere dev. So that's all listed in our architecture diagram. So this listed here, as you can see, the Prometheus, Grafana, Validity, and Fluentbit all forward to CloudWatch. And next one. I've also included a very powerful software, Kubernetes Lens. So it will monitoring the cluster and show all the memory usage and the pods logs as well. So next. There is something we can improve in the future. Thinking to add more customized metrics in the code to push to Prometheus for monitoring and integrate AWS SNS and alarms with the Prometheus. So once there's a alarms triggered, it will push to through users or the DevOps team through the SNS. And the last one is implement efficient log aggregation for the CloudWatch, so we can get rid of like some unnecessary ones by increasing the log intervals and try to save the cost as well. So that's it. Thank you for watching.